Hello, everyone. So my name is Alex Taylor, and I'm a PhD student at the University of Bath. I'm a member of the Art AI Centre for Doctoral Training. I am working in collaboration with Rolls-Royce, and I'm researching the application of artificial intelligence in safety-critical engineering. I have an undergraduate degree in aerospace engineering and an MSc in data science. I'm interested in the technical side of enabling interpretability and trust in AI. A bit more on Art AI. There are a number of other PhD students at the centre with me. We are an interdisciplinary group. We are a mix of social scientists, engineers, and computer scientists. We have people with backgrounds in law, education, and commerce, alongside those with a background in computer science and engineering. Some of my peers are more interested in the ethical and social side of AI, whereas myself and others are focusing on the technical side. However, all of our work relates back to the core themes of accountability, responsibility, and transparency in AI. Art AI has a number of partners, of which Rolls-Royce is one. We are primarily funded by the UKRI, which stands for UK Research and Innovation. The UKRI is a government body which funds research at universities, businesses, and charities across the UK. Its goal is to, quote, catalyse an inclusive research and innovation system that connects discovery to prosperity and public good. As AI is an up-and-coming technology with a lot of potential and excitement, the UKRI has funded 16 AI-related centres for doctoral training across the UK. Each one of these accepts PhD students, gives them a talk component for 1 year, and enables them to research their own topic related to their theme for the next 3 years. We can see there is a great variety here of what people are doing. We have Cambridge looking at environmental risk, Imperial looking at healthcare, Bristol looking at interactive AI, and Bath looking at accountable, responsible, and transparent AI. The main goal here is to catalyse AI research within UK universities and ensure the UK has a stream of upcoming expertise in this field. We can see that money is being put into academic research, and it's fair to ask why. This moves me on to my next point, which is the role of academic research in the grand scheme of things. Compared to industry, academia tends to have slightly more flexibility in its research. This is because there is less need for a direct economic benefit. Academia can research for the sake of curiosity. This is referred to as blue sky research. One can think of this type of research as high risk, high reward. High risk in that it might just not work with no return on investment. An example of this is the current AI boom we find ourselves in now. 10 years ago, not many people were interested in neural networks. Despite neural networks being around since the 50s, they hadn't been shown to be overly useful, and people didn't believe they had much potential. Back then, people were more interested in rule-based systems where specific rules are hard-coded by the engineers, as opposed to systems that purely learn from the data. However, a PhD student from the University of Toronto called Alex Krizhevsky changed this. He used a GPU, which stands for Graphical Processing Unit, to train a convolutional neural network to classify images. In other words, the neural network states whether the image contains a dog or a person or a plane and so on. He entered the algorithm into an image recognition competition in 2012 and won by a large margin. This sparked the massive interest in neural networks. For those not familiar with neural networks, these are machine learning algorithms behind many of the recent advancements in AI. The advancements in self-driving cars, speech recognition, and language processing are all driven by neural networks. Neural networks are trained by consuming huge amounts of data, and they learn to spot patterns in this data. Alex Krizhevsky was undertaking blue sky research at the time, as there were not many people interested in neural networks back then. Neural networks are inspired by the biology of the human brain. The human brain has billions of neurons which connect to form a complex network. This allows humans to process complex information. A simple neural network is shown on the right. It works as follows. Each node holds a number, and this number is multiplied by the strength of the connection, in other words of weight, to contribute to the node in the next layer. This continues throughout the network such that information is manipulated based on the weight of these connections. The weights enable some information to propagate through the network and some information to be ignored. The final node in the network is the output, and this represents the network's prediction. For image recognition, the input data would be the values of the pixels. To train the network, the values of these pixels would be propagated through the network to produce an output. The output is compared to what the output should be for that image, in other words, the label attached to the image. The connections or weights in this network are then mathematically changed to make the output of the network closer to the correct label. This happens over thousands of images. This enables the neural network to learn to classify images with a high accuracy. Back to the image recognition competition I mentioned earlier. Here we can see the error rate of the competition for different years. In other words, what percentage of images were incorrectly classified. This means a lower score is better. As we can see, 2012 had a huge improvement, and there has been improvements every year since. It was in 2012 that the convolutional neural network was entered into this competition. For this competition, the algorithms are trained and tested on the ImageNet dataset. This contains over 14 million images and is organized into over 21,000 categories. As we can see, a human has a 5% error rate, so the AI started beating the human at this specific task in 2015. Whilst this shows the results for the image classification competition, it is a similar story across all subdomains in AI. Language processing, computer vision, and reinforcement learning have all enjoyed huge developments thanks to the neural network research inspired by this result back in 2012. Whilst academic research arguably started this back in 2012, the tech industry caught up very fast. Big tech has since poured huge amounts of money into artificial intelligence research. This has produced a lot of further advancements in the field and has given the community many open source tools. Marketing departments and the media have also caught up, and AI finds itself surrounded by a lot of excitement and hype, both positive and negative. People call this period of advancements and prosperity an AI summer. This brings us to where we are today. From my point of view, AI technology is delivering, and there is real substance behind the hype. This means there is a lot to be excited about. My point from this story is that all this was started by a PhD researcher trying out something new with no obvious benefit. In other words, someone doing blue sky research. You may be wondering how this relates to ethics, which is the focus of today's conference. Well, I believe research into ethics will be a similar story. I believe academia will play a major role in investigating the ethical and social effects of AI. Academia can provide analysis with less potential for bias. It can also start a public conversation. What I mean by this is that different institutions will publish their own findings and opinions on different matters, and other institutions can respond to those. Over time, this will bring together different groups of people, and a standard will start to form of what acceptable uses of AI are and what are not. Academia can also look into examples of what happens when ethics is not considered. For example, if a biased AI algorithm is put into production, and how this could detriment society and individuals. I think there are three main ways in which academia can influence ethics in AI. These are through the education of their students, their influence on policy and regulation, and then through research into algorithm design. The first one is fairly self-explanatory. For better or worse, many jobs require candidates to hold a degree. This means that values that universities deem important and drill into students will be carried through into industry. This means that if ethics is kept at the forefront of any conversation about AI, tomorrow's leaders will hopefully remember to consider ethics when they're building the AI applications of tomorrow. An anecdote to this is the consideration ethics is given in healthcare education. Arguably, this results in medical workers being very conscious of the ethical implications of their decisions. A similar approach could be taken in AI work. Policy and regulation ensure that companies do not act unscrupulously and place limits on what companies can and cannot do. Governments are catching up with the recent boom in AI technology and are setting up policies and regulations. When drawing up these rules, academics and industry experts collaborate together. This means ideas and concerns in academia will result in real regulations that businesses must follow. For example, a computer science professor called Virginia Dignam from the Umeå University in Sweden sits on the EU board for AI regulations. On this topic, a draft of the upcoming EU regulations regarding AI was leaked about a month ago. This includes restrictions such as banning high-risk AI that is designed to manipulate people, for example, social scoring and indiscriminate surveillance. The requirements also mean that special authorization will be required to use biometric identification, for instance, facial recognition. The document also outlines the need for rigorous testing for anything dangerous or sensitive. This means algorithms will have to be tested for their safety and bias. Social scoring is an interesting point here, because social media could be viewed as a social scoring system. For example, social media is designed to manipulate people to spend more time on the app and has been used in the past to manipulate voting. The number of likes or followers could be interpreted as a score. It will be interesting to see if these regulations result in a change in the way AI algorithms are used in social media in the EU. These regulations will have been influenced by research done in academia. Whether the UK copies this legislation or writes their own remains to be seen. This brings me on to my third point, which is that academia may shape ethics through algorithm and process design. This is more related to my own research. Neural networks have near human capabilities at many specific tasks, in other words, narrow AI. However, they are notoriously bad at giving reasoning behind their decisions. They give an answer, and that is that. This is a major problem with neural networks. Other algorithms, such as decision trees, completely explain their decision process. However, these are nowhere near as accurate as neural networks. The explainability of algorithms has a direct influence on how they can be used and the ethics of using them in certain situations. If an algorithm can completely explain its reasoning, one can be confident it is not breaking discrimination laws, and clients, engineers, and regulators will be more likely to accept its answer. This means there's a lot of work in developing algorithms or processes that are both explainable and accurate. There is also a lot of value to be found in creating systems that can untangle neural networks and explain why neural networks make certain predictions. Industry, government, and academia will need to work together to shape AI technology and ensure it benefits all. Academia will continue to conduct blue sky research, influence policy, and teach values to its students. However, as big tech is now funding a lot of academic research, we must ensure that this doesn't create a bias in the research. Industry will commercialize AI for their specific applications. Governments will fund the necessary research and provide regulation to ensure AI benefits everyone. Thank you for listening. If you would like to stay in touch, feel free to email me or find me on LinkedIn.